Hi everyone, this is Tanya Chu. Today's video is a little bit special. One of my subscribers reached out and requested a step-by-step explanation for AS Physics October-November 2022, Paper 1, Variant 1. Let us get started. The paper that I'm going to discuss in this video is Cambridge International AS Physics, Paper 1, Multiple Choice, October-November 2022, Paper 1, Variant 1. So let us get started. Number 1. What is needed to accurately represent all physical quantities? Now you have to bear in mind, physical quantities are the quantities which can be measured or can be calculated by using apparatus available in the lab. So physical quantities must contain magnitude, numerical magnitude, as well as unit, whichever appropriate. So the answer is C. Number 2, a voltmeter connected across a resistor in a circuit reads 3.6 volt. What could be the current in the resistor and the resistance of the resistor? Now, current, resistance, as well as voltage or the PD, that is related to Ohm's law. You can use Ohm's law to do this. Since I have choices of the currents, different values of the currents and resistance, I just multiply the value of the current and the resistance and to match with the reading on the voltmeter. So I try A first. 150. Oh, this question is basically testing you on your prefixes. Milli is one of the prefixes, carries 10 to the power of negative 3, multiplies by resistance 0.24. Kilo is 10 to the power of 3. 10 to the power of 3. So I got 36 volt. A is definitely not your answer because we need to get 3.6 volt. B, 15 milli. Milli is 10 to the power negative 3 times 2.4 kilo is 10 to the power of 3 and I got 36 volt as well. B is not the answer. C, 1.5 milli is 10 to the power negative 3 multiplies by 0.24 mega. Mega is 10 to the power of 6. The answer was 3600, 3600 volt. Therefore, C is not your answer. What about D? 15 micro. Micro is 10 to the power negative 6 multiplies by 240 times 10 to the power 3, that is kilo. I got 3.6 volt. Therefore, the answer is D. Number 3, in an experiment to determine the acceleration of free fall, G, the time T taken for a ball to fall through a distance S is measured. The percentage uncertainty in the measurement of S is 2%. The percentage uncertainty in the measurement of T is 3%. The value of G is determined using the equation shown. G is equal to 2S, 2 multiplies by S divided by T squared. Now, when you look at the equation, this equation involves division and power factor. That means T to the power of 2, that's power factor. So the question asks you to find the percentage uncertainty in the calculated value of G. If an equation involves multiplication, division, or both, or factor of a power factor, then you need to add the fractional uncertainty. So to find, I would add the fractional uncertainty of G first, delta G over G. 2 is a number, there's no fractional uncertainty for 2, S delta S over S plus T squared. T squared, you take the power, which is 2, multiplies by the fractional uncertainty of T. Since we have already formed the equation involve fractional uncertainty, to find the percentage uncertainty, you just times 100. So multiplies by 100%. This is the percentage uncertainty of G. Delta S over S times 100%, that is the percentage uncertainty of S, which is 2%, plus 2 times the percentage uncertainty of T, which is 3%. So that is why this is 2% plus 6%. That gives you 8%. The answer is C. Number 4, which quantity is a vector quantity? A vector quantity is a quantity consists of both magnitude and direction. The answer is A, momentum. Speed is a scalar quantity, temperature is a scalar quantity, and Young modulus is also a scalar quantity. Now, number 5, a particle accelerates from rest. The graph shows the variation of the velocity v of the particle with time t. Which graph shows the variation of the velocity v with the acceleration? Now, there is a new physical quantity, which is acceleration of the particle. But the graph given is the graph of velocity against time. How do I find the acceleration from the graph? When a graph is being given, this is a graph of velocity against time. To find the acceleration, remember, acceleration is gradient of the graph. This is a straight line graph. This is called a straight line graph starting from origin. Therefore, the gradient of the graph is always constant. Straight line graph or linear graph will give you a constant gradient, right? That is also means that acceleration is constant. So we have to see here, A, it means that the velocity increases, acceleration is also increasing. That is wrong. B, it means that you see the value of acceleration is changing when the value of v is changing. So that's wrong. C, the acceleration is changing, but the v is constant. That is wrong. D, the value of v are changing, but the acceleration remain at one fixed value. That is why the answer is D. Number 6, the graph shows the vertical velocity of a parachutist during the first 20 seconds of her jump. Approximately how far does she fall before opening the parachute? This is a graph of velocity against time. That is why if you want to find how far of the distance the parachutists fall before opening the parachute, this is the point where the parachute is being opened. Right, so you have to find the distance. This is a velocity time graph. To find the distance, it is the area under graph. And the area is the area before the parachute is being opened. So I have to draw something right here. Okay, the area of this part. The area of only this part before the parachute is being opened. So I have, okay, this part seems to be like a straight line graph to me. So I am going to find the area of triangle first. Area of triangle, which is half times 1, 2, 3. This is 3. This is 28. So I am going to, okay, times half times 3 times 28. And I got 42. And then, the second part of the graph, this is a curved graph, right? It is not a straight line graph, it is a curved graph. Right, I know some of the physics students are taking at math. So if you're taking at math, you definitely know that to find the area of the curve, you need a function to be integrate. So the function must be integrated. So, but in physics, some of the physics students are not taking at math. So that is why, right, we don't give you any integration. But, okay, we need to calculate the area under this curve. How do we calculate? We count the number of boxes involved. So I'm going to split this into, okay, 2. Okay, you try to draw as small box as possible, smaller boxes here, and then you calculate the number of boxes under this curve and then multiplies by the area of one box to get your area under the curve. But this method is definitely very inaccurate, but we have no choice. This is the only method that we can use. Okay, so I'm going to draw this box. like this. Okay. Then like this. Okay, this part. And then, okay, that's all. I'm going to keep my ruler. So you calculate the number of boxes involved. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, maybe about 13. So I will say that area under the curve, okay? So I have 13 boxes and multiplies by the area of one box. The area of one box, okay, I choose x-axis. I have two boxes. So 2 multiplies by 20, the height. And I got 520 right here. Right, so the total area, right, total distance is equal to 520 meter plus 42 meter. So I have 562 meter, approximately 570. So that is why the answer is B. Now, number 7, what is the definition of linear momentum? Linear momentum itself represents a moving mass. As long as the mass is moving, the mass has momentum. So the definition of momentum, linear momentum, is the product of velocity and mass. C is the answer. Number 8, a mass of 0.2 kilogram is suspended from the lower end of a light spring. A second mass of 0.1 kilogram is suspended from the first mass by a thread. The arrangement is allowed to come into static equilibrium. Static equilibrium means the whole system is not moving. And then the thread is cut right here. Right, immediately after the thread is cut, what is the upward acceleration of the 0.2 kilogram mass? 1. Okay, now when you see that a thread is being cut, you know that 0.1 kilogram mass will go downwards due to its weight, agree? And the 0.2 kilogram mass will move outwards due to the force applied on the 0.2 kilogram mass by the spring to pull it upwards. So I would say that, okay, when the thread is being cut, the outward force experienced by the 0.2 kilogram mass is equal to the downward force experienced by the 0.1 kilogram mass. So upward force is equal to ma. Downward force experienced by 0.1 kilogram mass is its weight, which is mg. I cannot cancel the m because these are the two different masses. So 0. The ones that experiences outward force is 0.2 kilogram multiplies by a is equal to the one that is experiencing downward force, which is 0.1 kilogram mass times 9.8. So A is equal to 0.1 multiplies by 9.8 divided by 0.2. And the answer is 4.9 meter per second square. A is the answer. Number 9, a snowflake and a raindrop are in still air. They both fall from rest at the same time and from the same height, far above the ground. The snowflake and raindrop contain the same mass of water. Assume that there is no evaporation or melting. Also assume that for a given speed, the drag force on the snow flake is greater than the drag force experiences or by the raindrop. Which statement about the snowflake and raindrop is correct? Now let us look at A. The raindrop takes more time than snowflake to reach terminal velocity. Yes, that is true because the drag force or the resistive force experiences by the raindrop is lesser. That is why this is correct. Let us look at B. The raindrop takes more time than the snowflake to reach the ground. So I would say that this is wrong because since the drag force acting on the snowflake is larger, so the snowflake would achieve the terminal velocity. Terminal velocity means that there is no acceleration. Acceleration is equal to 0. So the snowflake would will achieve the constant maximum speed, which we call it as terminal velocity, faster as compared to raindrop. So the raindrop, because it is still experiencing acceleration, it accelerates. Snowflakes stop accelerate first, but the raindrop is still accelerating. So that is why raindrop would take lesser time because it experiences acceleration. When the snowflake has already stopped accelerate, raindrop is still accelerating. So accelerating, that means it moves faster, so it will take shorter time or lesser time to reach the ground. See, they reach the same terminal velocity. It cannot be true. Why? Because the drag force experienced by the snowflake is larger than the raindrop. So they cannot reach the same terminal velocity. D, they take the same amount of time to reach the ground. It cannot be the same as well because the drag force experienced by the snowflake is larger as compared to the drag force experienced by the raindrop. That is why statement A is correct. Now, question number 10. Two trolleys are held together on a horizontal surface with compressed spring between them. When they're released, the trolleys lose contact with the spring. The trolley of mass 2 kilogram moves to the left with a final speed of 2 meters per second. How much elastic potential energy was stored in the spring? Elastic potential energy stored in the spring is depending on, because based on the principle of conservation of momentum. So these two trolley is compressing the spring. So the spring has elastic potential energy. When the trolleys are being released, this elastic potential energy of the spring is being converted to kinetic energies of the two trolleys. So you need the speed of that 1 kilogram trolley. Or else, how do you find the kinetic energy? Because elastic potential energy of the spring is equal to kinetic energy of two trolleys. So you bear that in mind. I am going to use the principle of conservation of momentum. Total momentum before equals total momentum after. Total momentum before, because these two trolleys are not moving, total momentum before is equal to 0. But total momentum after, I want you to pay special attention. Trolley, 2 kilogram trolley of 2 kilogram is moving to the left. That means trolley of 1 kilogram is moving to the right. I am going to put positive to trolley, the direction of 1 kilogram trolley, and negative to 2 kilogram trolley, because this is about velocity. Momentum is about velocity. Velocity depends on direction. So I'm going to put, okay, 2 kilogram times negative 2 plus 1 kilogram times V. So I have negative 4 plus V is equal to 0. V is equal to 4 meter per second. So elastic potential energy of the spring, EPE, is equal to half mass of 2 kilogram trolley times the speed of 2 kilogram trolley plus half mass of 1 kilogram trolley times the speed of 1 kilogram trolley. So when you add this up, you should get, oh, this is 4, this is 8. So the answer is 12 joules. D is the answer. Number 11. A square board of side length X hangs freely from a nail P as shown. The board has uniform thickness and is made from the material of uniform density. A second square board of side length 2X is made of the same material and has the same thickness as the original board. The second board is then hung from a nail Q. Nails P and Q are at the same height. What is the vertical distance between the position of the center of gravity of the two boards? Okay, now I need to find, let's say this is a center. This is also another center. Take a ruler. Take a ruler. You can see that I need to find the distance, okay, between the two centers. Okay, this is another centers right here. Keep my ruler. Distance between the two positions. This is D. Okay, let us look at the small board first. From here, I need to find this length first. I call this as dp. Is that okay? Because it is related to nail p, so I say dp. So dp, this is 90 degrees. You can use Pythagoras theorem to find the hypotenuse. So dp square is equal to x square plus x square. So dp square is equal to 2x square. That is why dp is equal to square root of 2x. But I want from the middle, I want dp over 2. So that is why dp over 2, okay, is equal to square root of 2 divided by 2x, dp over 2. Now, I find the distance of q from one side to the other side. This is dq. Now, dq is the same thing. This is 90 degrees. So you find dq square is equal to 2x square plus 2x square. So dq square is equal to 4x square plus 4x square. dq square is equal to 8x square. But I want only dq over 2. This is dq over 2. So, okay, dq first. dq is square root of 8x. So I want dq over 2, so it is square root of 8 divided by 2x. So the vertical position is the difference between dq over 2 and dp over 2. Or I put this with another name, I put r. Is that okay? I don't want to confuse you with the 2. So I want the radius of the radius. Okay, just put the radius r and r. So I call this as r, not to confuse. Okay, r. So the r is like a radius, so you have to divide by 2 because the one dp means diameter. dq means diameter. So this is rp, this is rq. So if you want to find the vertical distance between p and q, okay, you just take, okay, rq minus rp. So vertical distance. RQ is equal to square root of 8x. Where is the x? Okay. Over 2 minus square root of 2 over 2x. So I simplify a little bit. 8 is equal to square root of 4 times 2x. Over 2 multiplies by minus square root of 2 over 2x. So square root of 4 is equal to is equal to 2. So 2 square root of 2x over 2 multiplies by square root minus square root of 2 over 2x. So this is 2 square root of 2. So you get square root of 2x over 2. So, but I don't see any answers here. Okay, just further simplified it. Square root of 2 is equal to 2 to the power of 1 over 2. X you just put aside. 2 is to the power of 1. Shift up the power of 1. So 2, 1 over 2 minus 1 times x. So I get 2 negative 1 over 2x. Or I can put x over square root of 2. Shift down. So B is the answer. Wow, so complicated. Even physics deals with math. Now, the next one, question number 12. Forces are applied to a rigid object. The forces all act in the same plane. In which diagram is the object in equilibrium? Remember, there are two conditions for object to be in equilibrium. First condition is when the resultant force acting on the object is equal to 0. Second condition is when the resultant moment on the object is equal to 0. That also being said that anti-clockwise moment is equal to clockwise moment. Right, now let us look at A. A upward force, F up, is equal to F. Downward force is equal to F. So I can say that the resultant force is equal to 0. Okay, A has already fulfilled the first condition. What about resultant moment? So I set my pivot here. This is my pivot at the center. And at the center. Now, here, 1 over 2F on the left-hand side going out while turning towards the pivot. This is called clockwise moment. 1 over 2 over F on the right-hand side turning towards the pivot. This is anti-clockwise moment. Since F is at the center, so I would say that, okay, this is distance D. This is also distance D. Could you see that clockwise moment is equal to half F times D? Anti-clockwise moment is also half F times D. So A is in equilibrium. But let us check B, C, and D. So B, total outward force is equal to 2F. Downward force is equal to 2F. Okay, fine. Now I set my pivot here at this point right here so that I can cancel the two forces there. So force, this, okay, this is D, this is also D. Now the downward force here going down while turning towards the pivot, this is called anti-clockwise moment. The upper force here going out while turning towards the pivot, this is also called anti-clockwise moment. So I can only see anti-clockwise moment produced by these two forces, but I don't see any clockwise moment to be balanced. That is why B is not in equilibrium. What about C? Total outward force is equal to 2F. Total downward force is equal to F. So C is not in equilibrium because the first condition is not being fulfilled. D, total, this is up and down, cancel. This is up, this is down, cancel as well. You can see that total outward force is equal to total downward force. But what happens? Okay, I set my pivot here because I can eliminate the two forces. Now, I said that this is the distance D. This is the distance D over 2. Could you see that the distances are different? So, but I will do my calculation. 1 over 2F going up while turning towards the pivot. This is anti-clockwise moment, which is half F times D. And 1 over 2F going down while turning towards the pivot. This is clockwise. Clockwise is equal to 1 over 2F times 1 over 2D. So it is not equal. Anti-clockwise moment is not equal to clockwise moment. D cannot be the answer. Number 13, a rigid rod XY has negligible mass and length 75 cm. The rod is suspended from a fixed point P by a string attached to NX. An object of mass 11 kg is suspended by a string that is attached to the rod at a distance of 25 cm from NX as shown, which vertically upward force acting on NY of the rod would hold the rod horizontally in equilibrium. If you want equilibrium, okay, pivot is, okay, pivot, I'll set my pivot here, pivot. Now, vertically outward force at Y. This is Fy. Now I have identified the two forces first. These are the two forces. One is 11 kilogram, the weight of the 11 kilogram. Now the weight of the 11 kilogram is going downwards. The weight would be 11 multiplies by 9.8. Now let me do it first. 11 multiplies by 9.81. That gives you 107.91. Doesn't matter because this is not paper 4. You can write as many significant figures as you wish. Now, Fy going up while turning towards the pivot. This is called anti-clockwise moment. W, the weight of 11 kilogram going down while turning towards the pivot. This is called clockwise moment. So since the rod must be horizontally balance and in equilibrium, I would say that my anti-clockwise moment is equal to my clockwise moment. Anti-clockwise moment is my Fy multiplied by the perpendicular distance between the force and the pivot, 75 cm. And clockwise moment is 107.91 multiplied by perpendicular distance, which is 25 cm. Therefore, Fy is equal to 107.91 multiplied by 25 divided by 75. And I got 35.97 Newton, which I rounded off to 36 Newton. Number 14. This question repeated a few times. Now I read the question. First, the density of water is 1 gram per cm cube and the density of the glycerine is 1.3 gram per cm cube. Water is added to a measuring cylinder containing 40 cm cube of glycerine so that the density of the mixture is 1.1 gram per cm cube. Assume that the mixing process does not change the total volume of the liquid. What is the volume of water added? Now, this is related to density. I know the total density is equal to 1.1 gram per cm cube. Now, I write down the equation of density first, mass over volume. Now, it seems like I have the density of the water and I do not have, I only have the volume of the glycerine. Okay, I have the density of the glycerine as well. Okay, I want to find the mass of the glycerine first. Density of the glycerine, mass of glycerine, volume of glycerine, and the density of glycerine. Density of the glycerine is 1.3, mass of the glycerine I want to find, and then divided by volume of the glycerine, which is 40. Now the mass of the glycerine would be 1.3 multiplied by 40, which is equal to 52 grams. Is it 52? 1.3 multiplied by 40. Yes, exactly 52. And I would like to find in terms of the total mass here. Mass total is equal to mass of water plus mass of the glycerine. And then I modified the mass because I know that density is equal to mass over volume. So the mass would be density multiplied by volume. So mass total will be total density multiplied by total volume equal to mass of the water will be the density of the water multiplied by the volume of the water plus mass of the glycerine would be 52. I just put it in right away. Now the total density is 1.1. Volume, the total volume is the volume of the water plus the volume of the glycerine. So equal to density of the water, volume of the water plus 52. Now 1.1 times volume of the water plus 1.1 times volume of the glycerine, which is 40. I straight away times in 40 and equal to the density of the water is 1, volume of the water plus 52. Now I simplify 1.1 volume of the water plus 44 equals 1 volume of water plus 52. And then you simplify 1.1 minus 1. So you have 0.1 volume of the water. 52 minus 44, you get 8. Volume of the water will be 8 divided by 0.1, which gives you 80 cm cube. So the answer is D. Now, number 15. A box in the shape of a cube falls from a ship into the sea. The box lands with its lower face level with the surface of the sea. The box begins to sink, becomes totally submerged, and then sinks deeper into the sea. As the box sinks, its lower face is always parallel to the surface of the sea, which graph best represents the variation of the upthrust acting on the box with the depth of its lower face below the surface of the sea. Upthrust is a force. Still remember pressure is equal to force over area. Pressure, area of the box is constant. That is why pressure is directly proportional to the upthrust force. Pressure is equal to rho GH. So I want you to see this, the depth, the upthrust, and the depth. So the upthrust will keep on increasing when the depth of the box, okay, from the surface of the sea is increasing. But when the box is totally sinking into the seawater, there is no more depth because the box is entirely below right? Can you see? As the box sinks, right? So the box is totally below it, right? Below the surface of the sea. And when the box is stop moving, stop sinking, the depth, the H, reaches a maximum value. So that is why the upthrust cannot increase anymore. Upthrust must be constant after a certain depth. So C is the answer, right? When it's totally sinking and not sinking anymore, so it is the time where the upthrust is constant because the H does not increase anymore. Number 16, a spring is compressed by a mass as shown. Which statement describes the changes to the energy of the spring when it is compressed by the mass? Now, compressed by the mass, could you see that the spring is initially higher? So it has higher gravitational potential energy because it is away from the ground, but when the mass is pressing it down, it lowers its gravitational potential energy. So the spring will lose gravitational potential energy. Cannot be gaining, must be losing gravitational potential energy and gain elastic potential energy. Why? Because when it is being compressed, elastic potential energy of the spring is increasing. D is the answer. The next one, number 17. A man of mass 75 kilogram runs up a staircase consisting of 30 steps. Each step is 20 cm high. The man takes a time of 7 seconds to run from the bottom of the staircase to the top. What is the average rate of increase of gravitational potential energy of the man? So I find the change in gravitational potential energy first, or the increase in the GPE of the man first, which is equal to mgh. The mass of the man is 75, g is 9.81, and steps, 30 step, each step is 20 cm. This is cm, you got to change it to meter because gravitational potential energy must be measured in joules. That also being said that the h must be in meter. So 20 divided by 100, this is 0.2 meter. So I times 0.2 meter and I got 4414.5 joules. It doesn't matter. Now I need to find the rate. Okay, so the rate, that means divided by time. So 4414.5 divided by 7 seconds. So you have 630.6 joules, watt, sorry. Divided by time, that is power. Energy divided by time is called power. So this is watt. So 630 is the answer. Now, number 18, an alpha particle has 2.2 times 10 to the power negative 13 joules of kinetic energy. What is the speed of the alpha particle? Now, before you calculate the speed of the alpha particle, write down the equation of kinetic energy, half mv squared. Alpha particle is the helium nucleus. Helium nucleus with the mass of 4U, unified atomic number. So you have to change that mass for U. 1U is equal to 1.66 times 10 to the power of negative 27. It is given, don't worry. This is called the mass of alpha is called 4U. Right? You have to convert to kilogram because the kinetic energy is measured in joules, which is 2.2 times 10 to the power negative 13 and times V squared. So the V is equal to 2.2 times 10 to the power negative 13 times 2 divided by 4 times 1.66 times 10 to the power of negative 27, and then you just square root that. You will get 8.14 times 10 to the power of 6 meter per second. C is the answer. Number 19, identical springs are joined in 4 arrangements. Which arrangement has the same spring constant as a single spring? I would assume that the spring constant is K. Now, these 2 springs are arranged in series. Series, remember, how are we going to find the total spring constant? 1 over K total is equal to 1 over K plus 1 over K. 1 over K total is equal to 2 over K. So that is why the total K is equal to K over 2. So this is not equal to K. A is not your answer. What about B? This is K, this is K. The two springs are arranged in parallel side by side. So the total K would be K plus K, which is equal to 2K. What about C? The two springs are arranged in series as well as parallel. So I'm going to solve for parallel first. These two springs, I get 2K, and then these two springs, I get 2K. So I simplified it to become something like this. In these two are parallel, so this is in series. Okay, this is load. So 2K and 2K. Done. And then these two springs are in series. So 1 over K is equal to 1 over 2K plus 1 over 2K. So 1 over K is equal to 2 over 2K. So that is why cancel the 2. K is equal to K. Right? It seems that this is the correct answer, but I will prove D is wrong. These two are in parallel. You solve for parallel first. You get something like this. This will be 2K. Parallel, you just add them up in series with K. Look, okay, this is K. 1 over K is equal to 1 over 2K plus 1 over K. So 1 over 2 plus 1, that is 1 over K will give you 3 over 2K. That is why the K is equal to 2K over 3. This is not the answer. I need K. So C is the answer. Number 20, an unstretched spring has a length of 2 cm. That is the original length of the spring. And the spring is then stretched within its elastic of limit of proportionality by a tensile force of 1.5 Newton, so that the elastic potential energy stored in the spring is 0.045 joules. What is the stretch length of the spring? Now, I need to find the extension of the spring first. From elastic potential energy, EPE, is equal to half Fx. Remember that? Now I want to find the x. 0.045 is given. That is elastic potential energy. F is given 1.5. From here, I can find my extension. My extension would be 0.045 multiplied by 2 divided by 1.5. So the extension is actually equal to 0.06 meter. Right? Or 6 cm. No worries. Okay, or I get it as 6 cm. Is that okay? Now the stretch length is the final length. Stretch length. When the spring is being stretched, of course the length becomes longer. So you need to add the extension plus the original length. So it gives you 8 cm. D is the answer. Number 21, a signal generator, amplifier, and a loudspeaker are used to produce a different sound waves in the air of a room. The relationships between the properties of these waves are investigated. Which relationship is not correct? Amplitude is proportional to wavelength. This is not true. Right. What about B? Frequency is inversely proportional to wavelength, V equal to F lambda. When the wave speed is constant, F is inversely proportional to wavelength. This is true. C, intensity is proportional to amplitude square. That is true. Period is equal to reciprocal of frequency. This is also true. True and true. A is the one that is incorrect. Number 22, when a guitar string is plucked, it causes a longitudinal sound wave in the air, as shown. The speed of the sound in air is 340 meters per second. What is the approximate frequency of the sound wave shown? So speed V equal to F lambda. Now, since this is a distance given, we can find a wavelength. Right, wavelength could be, okay, starting from compression, center of compression to the center of the next compression. Right, from 0, this is, I would say, approximately 0.5 meter. So the wavelength is 0.5 meter. Wave speed is 340. Frequency times 0.5 meter. So F is equal to 340 divided by 0.5, and I got 680 hertz. That is B. Now the next one, number 23. A transverse wave travels along a rope. The diagram shows the rope at time t equals to 0. The wave is traveling from left to right. This is super duper important. The period of the wave is t. And one particle at the rope is labeled x. Which graph shows the variation with time of the displacement of particle x between time equal to 0 and time equal to 2t? I want you to see this. You see, time equal to 0, look at x. X is at equilibrium position. Right, when x is at equilibrium position, x must start from 0. A is correct, B is correct. Say no to C, say no to D. Why? Because at time equal to 0, x seems to have displacement, but x is located at equilibrium position. Since the wave is traveling from left to right, all you need to do, maybe you draw another wave, shift the crest, shift the trough a little bit to the right. So this is a wave. Okay, the next wave. And after that, it is still moving. Right, okay, moving, shift. Okay, you could see that the wave profile is shifting towards the right, indicating that the wave is traveling from left to right. And look at this particle X compared to the two waves that I draw, wave profiles that I draw. It seems like wave X, particle X will vibrate downwards. So it will go down. So B is the answer instead of going up. Now, question number 4. A jet aircraft travels at a speed of 0.8 v, where v is the speed of sound. The aircraft directly approaches a stationary observer. The frequency of sound emitted by the aircraft is 100 hertz. Which frequency does the observer hear? Right, don't worry. Just write down the formula first. Observe frequency, F source times the speed of sound, divided by, I want you to see this, approaching. If this is approaching, you take V minus V of the source. So the observed frequency will be, the frequency of the source is 100, and this is V over V minus 0.8 V. Right, okay, and the V you can actually cancel off. This is 100 V. This is, you factorize up the V, you get 1 minus 0.8. Could you see that? So this is 100 divided by 0.2. And 100 divided by 0.2, and I got 500 hertz. D is the answer. Now, number 5, a telescope detects and analyzes some electromagnetic radiation of wavelength 2 cm. Which type of telescope? This is in cm, 2 cm, this is microwave. For question number 26, two waves of the same type overlap. When does the principle of superposition apply? Principle of superposition states that the resultant displacement of the two waves that meet at a point, that also means that the two waves must be, whether they are traveling in the same direction or they are traveling in the opposite direction, as long as the two waves meet at a point. So the resultant displacement is equal to the sum of the individual displacement. So that also means that, okay, it always, two waves, as long as they overlap at one point, right? Principle of superposition is always applicable. And number 27, a stationary sound wave is formed in a tube of length L that is closed at one end. The diagram shows the positions of the nodes and the antinodes of the stationary wave. Which graph shows the variation of the amplitude of the wave with distance x measured from the closed end of the tube. So the closed end of the tube has to be node, so it has to be 0 amplitude. And bear in mind, amplitude is a scalar quantity, so we cannot take the negative value. So here we can see that there are two antinodes. That means there are two positive maximum peak. Right, between A and C, for C, there are three antinodes. But from the diagram that is given, there are only two antinodes and two nodes. So two zero displacements and two maximum. amplitude. Maximum displacement, right? It is the scalar. Amplitude is the scalar quantity. So that is why all the values of the antinote must be positive. So A is the answer. Now, number 28, a wave on the surface of water passes through a gap between two barriers and is diffracted as shown. What happens when the frequency of the wave is half? Could you see that this is a wave, the same type of wave, so the speed of the wave is the same? I'm going to use the wave equation, V equal to F lambda. The speed of the wave is equal to frequency multiplied by the wavelength. Now, V is constant. What happened when the frequency is inversely proportional to the wavelength? When the frequency is actually half, the wavelength increase double. So when the wavelength is increasing, which is almost equivalent to the size of the gap, maximum diffraction could occur. So more diffraction is observed. B is the answer. Number 29, observable interference fringes are produced using light from a double slit. The intensity of the light emerging from each slit is initially the same. The intensity of the light emerging from one of the slits is now reduced. One is brighter compared to the other one. So how does this affect the interference pattern? So the bright fringes will become less bright because initially when the brightness of the light from the two slits are the same, so you get 100% constructive interference, so you will get maximum brightness. But now one is reduced, maybe one is with amplitude A, the other one is with amplitude half A, so your brightness, the bright fringes will become less bright. Right, bright fringes becomes darker, bright fringes and dark fringes all become brighter. No, bright fringes become darker, so this is wrong. Bright fringes becomes darker seems to be correct, but we are going to look at the dark fringes. So initially when the two sources destructive interference, that means a crest meet a trough. Right, so you will get 100% darkness. But now, right, since one of the amplitude, due to the intensity that is now being reduced, one of the amplitude is lower as compared to the other amplitude. So maybe crest is A, but mid with the trough, this is half A. So you will get half A, even though this is destructive interference. So you would not get 100% darkness. So that is why dark fringes cannot become darker. It will become brighter. So it is not 100% darkness. See, the bright fringes become brighter. No, the bright fringes become darker and the dark fringes becomes brighter. Yes. Number 30, a diffraction grating has 4 times 10 to the power 5 lines per meter. This is N. A beam of light of wavelength 589 times 10 to the power negative 9 meter is incident normally on the diffraction grating. What is the angle between the second order maximum and the direction of the incident beam of light? Now, I am going to use the diffraction grating formula, d sine theta n is equal to n lambda. N is the number of order. D is the grating spacing. Grating spacing and the number of lines per meter, they are related. D is actually equal to 1 over n. So I'm going to replace D with 1 over n. Sine theta 2 is equal to 2 lambda. 1 over n is 4 times 10 to the power of 5. Sine theta 2 is equal to 2 times 589 times 10 to the power negative 9 meter. So you make sine theta 2 as the subject. So I'm going to make sine theta 2 right here. Sine theta 2 is equal to 2 times 500 is equal to 2 times, okay, is equal to 2 times 589. 589 times 10 to the power negative 9 divide, no, I have to times because 4 times 10 to the power 5, okay, not division. I rewrite this. Cross multiply So 2 times 589 times 10 to the power negative 9 multiplies by 4 times 10 to the power of 5. That will give you your sine theta. So theta 2 would be, shift the sign. So let me multiply 2 times 589 times 10 to the power negative 9 multiplies by 4 times 10 to the power of 5. And I got 2 times 589 negative 9 multiplies by 4 times 10 to the power 5. And I got 0.4712. So you shift the sign, you will get 28.1 degrees. So the answer is C. Now the next one, question number 31. A length of wire RS has a circular cross section. At NR of the wire, the cross-sectional area is A. At NS of the wire, the cross-sectional area is A over 2. Charge Q takes time T to pass through NR of the wire. This is charge Q, time T, where there is a constant. Oh, this is a key point right here. So I have to highlight this. There is a constant electric current in the wire. How much charge will pass through NS in a time interval of T over 4? T over 4. I want to find the time here. Now, the question did mention that there is a constant current. Now, I have to write down the relationship between current and other physical quantity. So, current is equal to NAVQ, where N represents the number of charge density, A represents the cross-sectional area, V represents the drift velocity, and Q represents the charge. Right, so current is actually related to, directly proportional to area. But now, cross-sectional area, A represents cross-sectional area, but due to the current is constant, this is constant. And this is the one that changing. So I would say that A, cross-sectional area is not affecting the value of the current. Cross-sectional area is not affecting the value of the current because the current is constant. Even though the cross-sectional area is changing, but the current is still constant. The same amount of current that flows through N of S and N of R. So that is why I use charge. I is equal to Q over T at N of R. And then I, the same I at N of S, okay? And this is NR, this is NS, the same amount of current, but the charge may be different. Charge as S divided by T over 4. So I would say that this is the equation 1. I compare between the two equations. Equation 1 is equal to equation 2. Q over T is equal to Q at S over T over 4. Now cross multiply, Q at S is equal to T over 4 divided by T, right? T over 4 times Q. Now T and T you can cancel, so you get 1 over 4 Q, or Q over 4. B is the answer. Number 32, a power supply is connected to a component by connecting wires of total resistance 4.9 ohm. The power supply has an output power of 3.6 watt and a terminal potential difference of 12 volt. How much thermal energy is dissipated in the connecting wires in a time of 1 hour? So I say that this is my power supply. Power supply connected to the wire, all the wire, and the total resistance of the wire is 4.9 ohm. Power supply has an output of 3.6 watt. And then terminal potential difference of 12 volt. How much thermal energy is dissipated? So I find the current that flows through the power supply first because power is given, and then PD of the power supply is being given. Power is equal to IV. So I find that I is equal to power over V, 3.6 watt divided by 12 volt. From here, I got 0.3 ampere. That is the value of the current that flows through the wire. Now, I want to find the thermal energy that is being dissipated in connecting wire in 1 hour. So energy E is equal to, oh, resistance of the wire is being given. So I'm going to use I square RT. Now I is 0.3, you just square it. Total resistance between the connecting wires is 4.9 ohm. And the time is 1 hour. 1 hour is 60 minutes. 60 minutes is, okay, 1 minute is 60 seconds. So you have to convert to second, right? Because your units of thermal energy is in joules. So when you multiply 0.3 square, multiplies by 4.9, multiplies by 60 times 60, you should get 1587 or 1.59. 1.59 times 10 to the power of 3 joules. So I round it off to 1.6 kilojoules. Number 33, a copper wire is to be replaced by aluminum alloy wire of the same length and resistance. Copper has half the resistivity. When you see the word resistivity, you have to relate your resistance to resistivity. So resistance is equal to rho L over A. But in this case, we are supposed to find the ratio of diameter of the alloy wire to the diameter of the copper wire. So remember, wire, cross-sectional area of the wire is equal to pi d square over 4. I just sub into this equation. I have R is equal to rho L pi d square over 4. Now, I want to find the resistance of the alloy wire and the copper wire have the same length and the resistance. So R is equal to rho of copper has the half resistivity of the alloy. So resistivity of the copper is equal to resistivity, half of the resistivity of alloy. So this is R, resistivity of the copper first. Okay, times the length of the copper, which is the same, pi d copper square over 4. Put this as equation 1. And then the R for alloy, rho alloy, length of alloy, pi d alloy square over 4. Now I replace this one. Okay, I don't want to put equation 1 just yet. I'm going to replace this resistivity of the copper as 1 over 2. 1 over 2 rho of alloy. Then only I put in, okay, equation 1 is equal to equation 2. Now, half rho of alloy times the length over pi d. Oh no, okay, copper square over 4 is equal to rho alloy length over pi d alloy square over 4. Now, let me cancel whatever I can cancel first. I am going to cancel rho AL, pi over 4, pi over 4. Then I do my cross multiplication. Times out 1 over 2 d, diameter of the alloy square, equals diameter of the copper square. So I want diameter of the alloy over diameter of the copper. So push down, times it out. So this is 2. That is why diameter of the alloy over diameter of the copper is equal to square root of 2. So the answer is A. Number 34, 3 identical filament lamps P, Q, and R are connected to a battery of negligible internal resistance as shown. The filament wire in lamp Q breaks so that it is no longer conducts. What are the changes in the brightness of lamp P and lamp R? Could you see that initially, brightness of the lamp depends on the current and or potential difference across the lamp. Now, could you see that here? Current, let's say this is I. Initially, this is a junction where before Q breaks, this is a junction that split. these three lamps are identical. So this is I over 2, I over 2. But when lamp Q breaks, right, all the current, the new current will be I, will flow all the way I. So P will get the current of I. All the current will flow through P after Q breaks. So what happened to the brightness of lamp P? Lamp P will be brighter. What about lamp R? Right, lamp R, so yes, it is the same amount of current that flows through that, but the problem with lamp R is that, you see, P and R, initially the total resistance of the circuit is before lamp Q breaks, right? The total resistance of the circuit, okay, let me put this as, okay, R, R, and R. Initially, before Q breaks, initially, the total resistance is equal to, between Q and P, 1 over R plus 1 over R plus R. So that is the resistance of R. So this is 2 over R. So R over 2 plus R. Could you see that? So it is 3R over 2. 1.5 R. Now, when the lamp Q breaks, all the current will flow through P and R only. So the total resistance across P and R would increase. So due to the total resistance that is increasing, right, R would be dimmer as compared to before. That is why the answer is B. Number 35, which ratio has the same units as electromotive force? Electromotive force is being defined as the energy supplied per unit charge in moving the charge through a whole circuit, right? C is the answer. Energy transferred per unit charge. Question number 36. A circuit consists of a battery, a voltmeter, and 5 fixed resistors as shown. The voltmeter reading is 0. That also means that the PD at point A, I just put a point. PD at point B will be the same. So PD at point A is equal to PD across B. Now, what is the resistance of the resistor R? If you want things to be easier, I am considering, okay, I want you to consider to use potential divider. So I'm going to redraw this. Okay, how to redraw? Okay, I put this as 5 ohm right here. Oh no, I put this as 2 ohm first. 2 ohm first. Here, this is 2 ohm connected to 5 ohm potential divider. Yeah? And then this is the total PD. So I would find, right, okay. So the PD, point A and point B. Could you see that? So this is the V output, V out. So 5 divided by total resistance, which is 7, is equal to V output over V across AB. Done. And then I consider this circuit and I redraw the potential divider of this circuit. I got, this is, okay, I just find R total, the whole thing here, this is called my R total, okay, and then this is my 10 ohm, okay, this is my 10 ohm, this is A, this is also B, and then this is V output. So I'm going to use it, 10 divided by R total is equal to V output over VAB. Could you see that? Now I put this as equation 1 and this as equation 2. I say equation 1 is equal to equation 2. 10 over R total is equal to 5 over 7. Now you can find your R total right now. 5, this is 70 equal to 5 R total. So that is why the R total is equal to 70 divided by 5, which is 14 ohm. So 14 ohm is the R total between 10 ohm plus the resistance here, the total resistance here. So now, okay, R total is equal to 10 ohm plus 1 over R plus 1 over 8, and then you shift the total R between the 8 ohm and R, because 8 ohm and R are connected in parallel. So I have 14 is equal to 10 plus 1 over R plus 1 over 8, and then you invert. 14, you minus 10 first, you get 4 is equal to 1 over R plus 1 over 8, you invert. Now you want to get rid of that inversion, so I put 1 over 4 is equal to 1 over R plus 1 over 8. So 1 over R is equal to 1 over 4 minus 1 over 8. So 1 over 4, 1 over 4 minus 1 over 8, I got 1 over 8. So 1 over R is equal to 1 over 8. R is equal to 8 ohm. D is the answer. Let us look at question number 37. A battery of electromotive force, EMF, 6 volt, and negligible internal resistance is connected to a voltmeter and 4 other components as shown. The voltmeter is connected between points X and Y. Positive terminal of the voltmeter is connected to X and the negative terminal of the voltmeter is connected to Y. Initially, the resistance of each of the 4 components is 1 kilo ohm, which change on its own will cause the voltmeter to show a positive reading. If you want the voltmeter to show a positive reading, that also means that the potential at X must be higher than the potential at Y. Potential at X must be higher than the potential at Y. So since I am going to use the potential divider to explain, I need to show that the resistance at X must be higher than the resistance at Y. All these, the ones that I highlighted, will be resistance at X. Okay, resistance at X. Now, okay, this is the resistance of X. Okay, now I'm going to write that as resistance of X, Rx. Now, first of all, you have to understand this is called variable. This is LDR, light dependent resistor. This is called LDR. This is called thermistor. This is called variable resistor. Now, let us look at the first one. Decrease the temperature of the thermistor. When the temperature of the thermistor is decreasing, the resistance across the thermistor will have to increase. When the resistance across the thermistor increases, the Vy would be larger. So Vy would have to increase. So I don't want Vy to increase. I want Vy to decrease. So A cannot be the answer. B, increase the resistance of the variable resistor. So if you increase the resistance of the variable resistor, the potential difference across the PD across variable resistor would have to increase. And bear in mind, the total potential difference or the total voltage is equal to, because you see that the variable resistor and Rx, right, are connected in series. So it is equal to the potential difference across the variable resistor plus potential difference across X. See that? So 6 volt, this is constant. When the PD across the variable resistor increases, the potential difference across Vx is decreasing, so that it balances back. You get back the same value of 6 volt. Initially, for example, let's say the PD across the variable resistor is 3 volt. PD across X is also 3 volt. Now, because the resistance of the variable resistor is increasing, so the PD across the variable resistor will also increase. Let's say increases to 4 volt. Don't you think that to get back the 6 volt, V across X will have to decrease to 2 volt? So B is not the answer. C, reduce the intensity of light incident on the light dependent resistor. So when you reduce the intensity, the resistance of the LDR will have to increase. So the V across the LDR would have to increase. So the V across the LDR increases. You could see that the total V is equal to V across LDR plus V across thermistor. So 6 volt is constant. Initially it's 3 volt and 3 volt, for example. Now V across the LDR increases. Let's say increase to 5 volt. Don't you think that the V across the thermistor will have to decrease to 1 volt? When Vy is smaller than Vx, voltmeter will give you positive reading. So C is the answer. Why D is not the answer? Because when you replace the fixed resistor with a 500 ohm resistor, it also depends on the resistance of the variable resistor. What if you replace the fixed resistor with 500 ohm resistor, but the resistance of the variable resistor is 1000 ohm? So you could not, okay, voltmeter would still not show a positive reading. Question 38. An alpha particle passes close to a gold nucleus and is deflected through an angle greater than 90 degrees. Which property of the alpha particle changes as a result of the deflection? The one that is changing is B, deflect, okay, move away, so direction changes. Number 39, a nucleus of 23892U decays in stages by emitting alpha particles and beta negative particles, eventually forming a nucleus of 20682Pb. How many alpha particles and how many beta negative particles are emitted during the decay chain? So I write down the equation first, 23892U minus, maybe I put A, for 2 alpha particle is a helium nucleus, and minus B, beta negative fast moving electron, then I form 206 82 Pb. I compare the nucleon number first. Could you see that? 238 minus 4a minus negative b times 0 is still 0, is equal to 206. So 4a, so 206, 238, 4a. So negative 4a is equal to 206 minus 238. So 206 minus 238, you get negative 32. That is why A is equal to 32 divided by 4. A is equal to 8. So you need to choose 8 alpha particles. So I know that this is 8. This is 8. A is 8, right? So I replace with 8. Now I compare the proton number. 92 minus 8 times 2, 16. Minus negative B equals 82. So 92 minus 16, 76, minus negative and negative becomes positive, 82. So B is equal to 82 minus 76. B is equal to 6. A is the answer. That is how we do it. Now the last question here, which list of particles contains only fundamental particles? So the fundamental particles are antineutrino, yes. Beta, yes. Meson is no. B, baryon, no. C, electron, yes. Neutrino, yes. Alpha is not. D, lepton, yes. Quark, yes. Positron is yes. So D is the answer. Now that is all about October-November 2022 paper 11. If this video helped you, please remember you're not alone in this journey. If you have any questions or any paper that you do not understand or a topic that you are struggling with, leave a comment below. Don't forget to like, subscribe, and share this with a friend who needs help. And I will see you in my next video. Bye bye.